Hello everyone and welcome to another video on our YouTube channel, and this is a more beginner focused contribution video where we will be going over this repository called the Scikit-HEP project. And this is actually a repository meant specifically for research in high energy particle physics, and it is one of the repositories used by an organization called CERN. And the CERN actually stands for European Organization for Nuclear Research. It's called the CERN because it's translated into French, which translates into the initials CERN. And this is a Scikit-HEP project that has a number of different repositories. What we will be looking at today is a specific repository called Vector. So Vector is one of these repositories that focuses on adding more capabilities to the NumPy library, which is for numerical manipulation in Python, and make it more suitable for being used in high energy particle physics research. And if you know me, you know that I'm really passionate about physics. So I do try to contribute to some of the physics related project in my domain of expertise, that is software. And let's see how this goes today. And before we begin, we will be following a 13-step guide to contribution. So the number one step is finding a project which you have already done. It is the Vector project under Scikit-HEP for today. Reading the contribution and README guides. So let's go towards README. By default, usually the README is just below the repository. And the README for Vector has a very good detail about what the Vector library does. In short, just summarizing it for you, we usually deal with three coordinate systems, or what we call as a 3D axis when we deal with 3D objects or objects in real life. However, the vector library over here supports something called Lorentz vector, which usually have a fourth dimension, that is the dimension of time. And the speciality of Lorentz vector is that if you want to switch from one inertial frame to another inertial frame, the Lorentz vector use something called a Lorentz transformation to transform your vector coordinates from one inertial frame to the other so that they remain consistent. In this particular video, we won't be dealing and diving deep into the physics aspect of it, but we'll be just modifying and helping the contributors over here by doing some contributions to improve the code base. So if you don't understand the physics behind it, it's totally fine. So the README goes over quite a few things, including the installation. It also goes towards how you use these vector functionalities and libraries, and it gives you very detailed examples. It tells you how you build these vectors, or the different transformations you can use, so on and so forth. However, the most important thing that we need to focus on in this particular video is the contribution.md, and that is towards the end of this README file. So if you scroll down towards the very bottom, you'll see a link for the contributing.md. So let me open that in a new tab. And the contributing.md has the instructions on installing this locally. So as usual, we clone our repositories, and they are also very particular about creating a virtual environment, something that we always do as a part of our 13-step guide, and which we'll also do today. And building this is very simple. It just involves a pip install -e command, and we will be going through the steps for this. But it is very important for especially beginner-friendly projects to have such a detailed step-by-step guide, because it helps contributors like you and me to contribute to it without having the ambiguity of how to build it. So if you're making a project of your own and you want contributors, especially beginner contributors, to help you with your code, you should have a guide like this. It's a really good guide. Okay, so that completes our step 2, which is reading the contribution.md and readme.md. The next step is to look for relevant issues. And in this particular video, I've already selected an issue. And because I said it's a part of our beginner guide, we want an issue that is easier to tackle. And that is adding missing docstring for some of the properties and methods in this code base. So so the contributor wants us to add some documentations, and he has added the to-do comment that points to the examples where they need more documentation. They want more documentations in a file called numpy.py, and it has been linked over here. So if you open this link over here, it will open the file, and a simple Control F for the to-do label will give us the places where we need to add more documentation. So we need more documentation for the azimuthal part of the vector and the longitudinal. So vectors usually have an azimuthal component and a longitudinal component. Again, don't mock me for my pronunciation for azimuthal. I know it does go by different variants. Whichever you say is fine, as long as you understand what it does. And we'll see what it does very soon when we try to implement a demo file. But this is the issue that we will be tackling. Again, it's not a code change. It is more like adding an example, which makes it more clear of how we can use these two properties. And there are more than just two to-dos. There are actually five, if I remember correctly. We have two for 3D, two for 4D, and there's a last one that deals with the temporal one. And I won't be adding the description or an example for temporal because I want it to be an open thing so that you, once you see this video, you can actually go to this issue and add a PR, adding an example for the temporal one, so that you can also practice this entire workflow by yourself. So I'll just be adding examples for the 4 to-dos, not the 5th one. So the issue would still be open, most likely for some time, unless until someone comes and contributes to it. Okay, so we have chosen our issue, and the next step is forking and cloning the repository. And now begins the fun part, because now we'll start playing around with the code. Again, I have already forked this repository, but if you wanted to do it, you can click on this button over here. And if you already have a fork for this, it should be mentioned over here. So since I already do, I'll go to my existing one. And if you do have an existing one, it's always a very good practice to make sure that your repository is synced. So click on the sync fork button, and if it's not synced, you should sync it. The next step is we copy the URL for our repository. So after we get the link over here, we need to clone it. So pick up a place in your library where you want to, or your file explorer, where you want to save and start building it. Okay, so I already have tested this out, but let me start afresh. So what I will do is I'll create a new folder over here, and I'll just call this demo. And within the demo folder, I'll clone this repository. Again, in this tutorial, I'll be using the Git bash. It's very easy to download, and there will be a link in the description how to install the Git bash for Windows and Linux. It's also, I think it comes pre-installed with Mac OS. I could be wrong, but you can just install it via terminal. So once we have this terminal ready, we can just do a git clone and paste the URL we just copied. Perfect. So we did get a clone of the repository. Make sure that the clone is from your own account, right? It should be your username over here. Do not clone the actual repository. It might create some problems when you're pushing to it because you won't have permissions to directly alter the actual repository. So always clone your forked repository. Next step, once we do that, we need to create a new branch. We need to go inside vector and then make sure we create a new branch. And once you do that, the branch should be created. Next step is to set up a virtual environment. And make sure that when you go and create a new branch, the checkout -b, make sure that you actually go on to the new branch. You can also check it from the branch name over here. Many people make a mistake that they create a new branch and they forget to switch to it. Don't make that mistake. Okay, so once you've done that, we need to create a virtual environment. And to do that, as always, I'll be using something called the WSL, which stands for Windows Subsystem for Linux. There will be a link down in the description explaining how you can install that for Windows. And if you're using Linux or Mac, you can just use your normal terminal. It just gives you a Unix-like interface to play around with. So in this case, make sure that you're within the folder you want to be, and then you can create a new environment using the command python 3 -m venv venv. And I usually just call my environment env. You can name it whatever you want. This might take some time to create a new environment. So once the environment has been created, make sure we now need to activate the environment. It has not been activated yet. And to do that, you can simply source the activate command over here. And as long as you get an env or whatever your name of your environment is on the left-hand side, that's a good indication that you have set it up successfully. The next step is to follow the README guide. So let me go directly to the README. Oh, my bad, the contribution.md, and follow the steps over here. So once we have already created the virtual environment and we are within the repository, we need to make sure that we run these commands. So if you want to edit the docs, you can run this command. If you want to just work with the code, you can run this command. For the sake of completeness, we will run the one with the docs because we will be running a few tests to make sure that we're not breaking any of the documents. So we copy that command, and you can just copy that by clicking it over here on the right hand side, and we paste the command over here. Now there is one mistake that I usually make and I won't be making again, and that is I should be within the repository when I post this command. So we go within the repository, and that is where we post this command. Now, just a brief description, the -e stands for editable. That basically means that you are telling the pip or the Python installer that we want to make sure that this repository is editable. So any changes we make in the code will be reflected when we are importing this module. That's all it means. So once we have installed this repository, the next step is to set up the pre-commit install. So if you go to the README, it talks about how to activate the pre-commits. Now we have touched pre-commits in some of the earlier videos, but just to recap, pre-commits are the checks that happen on your changed files before you make a commit. So it's one step before you put a pull request. It's a very good practice to have pre-commits because it makes sure that you're only committing changes that abide by the rules and regulations of the repository. So if you're using Mac or Linux, you can just do that in the terminal. But because I use Windows Subsystem and Git Bash separately, I prefer installing the pre-commit in my Git Bash. So within the vector folder, we now need to run this command called pre-commit install. And that will install the pre-commit files in this particular repository. And the next step, just to verify that we have all the dependencies for pre-commit installed properly, we then paste this command, which runs all the pre-commit checks on the existing file system. So after we pass all the pre-commit checks, the last thing that we need to do is to make sure that we are able to run the PyTest locally. So to run them locally, the command that we will be using is python -m pytest, and make sure that you're using it in the place where you have set up the pip install -e dot repository, basically in our virtual environment. We don't want to do it on a Git Bash, which does not have the virtual environment. So that is where we will be running our PyTest, and you should expect all these tests to pass. You should see no failures, primarily because, again, we did not change anything, right? So why should it fail? So after some time, you should see that all the tests that you have run have been passing. And at this point, there's one test skipped, so you should be worrying about that. So we have done the installation of our repository, that is the vector repository, and we have cross-checked that the pre-commits are working, and so do the PyTests that they have set up. So all the unit tests that they have are also working. Now make sure that you need to do this, because if you skip this step, you might directly go into making the code changes. You could do that. But when you eventually make a pull request, these tests will be run internally on the upstream task. And the PR description will also recommend that you run these tests locally. Because trust me, many of these owners and the maintainers of these repositories, they're busy enough. And when they see that, okay, you push the PR that's failing all these unit tests and the simple code checks, that is frustrating for them. And it's also a bit, I'd say, embarrassing for you, because they have already mentioned that you should run all these tests before gaining attention of the reviewer or the maintainer. So be a good developer, make sure that you run all these tests, especially after you make your changes, so that you're not those people who are irritating and frustrating the reviewer that, hey, the test is failing, what should I do, right? And if you still fail some of these tests and you feel like you don't know what's happening, it's totally fair to ask them questions, but don't skip them just out of ignorance. Right? So having said that, having given my small pep talk, now let's go back to our 13-step guide. We have set up the virtual environment. The next step is to make the changes. So to make the changes, open your editor. It could be VS Code, Vim, whatever you want. And I've already made the changes over here because I've already put a pull request out there. And the changes over here are very, very simple. Remember that we just had to search for the keyword to do, and one of the 4 descriptions that we're going to add was from the azimuthal property. And all we need to do is we need to make an example that demonstrates how this property can be used. Remember, I call this a property because it has been marked by this decorator over here as a property, as it can also be accessed like a member variable, similar to, like, say, vec is the object, so vec dot the name of the property. Now, again, you could actually get this just by common sense and seeing some of the examples that they have given. But a good rule of thumb is that you should make sure that the examples you're putting over here, they reflect the actual operation. So I did create a file called demo.py. And just to show you the file system, the demo.py is outside the vector repository. We just have it over here. And in the demo.py, it's a very simple code. It's basically the example that I've added. So we import the vector repository. Remember that we had the pip install -e command, which means that it gets the vector from the local installation or the local file system, and not from our, pip install global repository, which is usually the place where we import these modules. So, and one other way to check that is you can also add print statements. That's something I've already done in when I was making the change, just to make sure that the vector repository that I am running locally corresponds to my local file system, so the print statements actually show up. And it's very easy to do that. You can just go to the property over here. You could literally just add a print statement. Hey, print, hey, who cares about the grammar? It's fine. HP was here. And that is pretty much it, right? And as long as you see this message when you run this demo code over here, you won't see it right now because it calls the longitudinal one. But if you do call the azimuthal one and you see this print statement, that's a good guarantee that you are running the local installation. And you should do this for all the 4 properties that I've edited. So longitudinal for 3D and 4D, azimuthal for 3D and 4D. And after you have verified that they are working, we add the example over here. Now, this is also a very general tip when you're contributing to a repository. The formatting of it. For example, the code over here is one tab to the right of example, and the code that you type is has a suffix, has a prefix of these 3 arrows, and the command that is continued has these triple dots, and the output does not have any of these annotations. Where do I get this format? How do I know this is the format I should follow? Simple enough. Look at other examples, right? This file is filled with other examples. Make sure that you are consistent with it, because every maintainer wants you to be consistent, and you should not be reinventing the wheel over here. And that goes for any code, not just documentation changes over here. So once we have added all our examples, the next step is to create a commit. And to create a commit, it's a very easy step. For example, I'll just make a commit for the hey HP was here. But again, let me open the file that corresponds to our demo lecture. So we go into the demo folder, we go to the vector. It should be within source and backends, and the file is numpy.py. And this is the unedited version, so I can literally just search for to do. We have this property where we had to add this example over here. So for the 3D azimuthal one, we want this example. So we copy this out and we paste it over here. Again, I can copy paste it because I have already made the changes. You won't have this luxury, so you have to add it for the first time. And all we need to do is make sure that we replace the stock string over here with our new example. And I'm just doing this to make sure that you understand the process of committing it. And after you made the change, make sure that you get rid of the to do. And we go back to our Git terminal. And let's just check the diff. So by now we should see that we have made some changes to the doc string. And that is exactly what we wanted. After we make this change, the first step is to add this file, and we can do that by doing a git add source vector vector backends. And what's the name of the file? Numpy. So we have numpy.py. You do see some of the other edited files. Make sure you don't change them, because many of these are hidden files within the GitHub folder that might have been created when we are running the test or the pre-commits. So just add your changes. And after this, you should see your file turn green in the Git status. That basically means that it's ready to be committed. It's already in the staged area. And to commit it, remember our 13-step guide. What does that say? It says that we should make our commit message descriptive. So we can literally just say added example for 3D azimuthal property in vector, right? Simple enough. That's exactly what we did. So we want to make it descriptive, concise, and to the point. Once we do this, remember that we already installed the pre-commits. And when we run this command, it will go through those pre-commit checks just to make sure that we are not violating any of the rules. All right, so the good news is we have passed all the pre-commit checks. And now what we need to do is we need to push this upstream. And before we do that, just check that the upstream is set to your own local version or the local copy of your repository. That is the forked version. And it is because I can see my username right there. So git push origin add examples for properties in vector. So what this does, and we can refer back to our 13-step guide. So once we have pushed the changes, it gets reflected in our upstream repository. And the next step would be to open a PR or a pull request. So we go back to our repository, make sure that it is the local version of your repository. And you should have a pop-up saying that this branch has recent pushes and we want to make a pull request. And you can literally click on compare and pull request. And you should be able to see your changes right below. You can confirm that the changes that you want to make are exactly being reflected over here. But the most important part is to look at this checklist. So the checklist has been provided by the contributors, and they want you to make sure that you have read the contribution.md. They want to make sure that there aren't any other pull requests that do the same change. So make sure that you do your due diligence before contributing or submitting a PR. Next step, the pre-commits. As I said, they are important, and they usually are run if you commit it and you have already set up the pre-commits. The PyTest, again, I've not run the PyTest right after making this change. I have already done that when I was making the actual pull request, and I've already shown you how you can run it. So make sure you don't ignore it. Ignorance is not excusable. The next step is we should also go to the documents and just do a make clean and make HTML. That will just make sure that we are not breaking any of the documents functionality. Now, yes, you can let me know that, hey, we never touched the documents, so why should we even run the test? For sanity check, right? How many times has a computer done something very absurd while you're expecting it not to do that, right? Computers can defy your expectations. So make sure that you always run these tests. And as I'm saying, let me just go to the documents folder over here. And to do that, you literally just have to do make clean. And again, make sure that you're doing it within your environment. And after make clean, just run make HTML, and you should be good to go. After we have completed making all the documentation, you should see a message over here saying build succeeded. As long as you're seeing them, it's fine to ignore the warnings. And once we have done that, we go back to our pull request. So we have done the pre-commit checks, the PyTest checks, we have made the documentations and make sure that they built without any problems. And we should also make sure that we also run the PyTest doc plus test. They also have a NOx or NOx version of running all these tests, which is explained in the contribution.md. You can set it up, but I feel that you can literally just run the normal PyTest commands and get away from using NOx, because NOx is an alternative that they have set up. But I feel it's very specific to this repository. In most of the repositories, you'll usually just come across PyTest and pre-commits. So it's good to experience and learn the first method rather than the second one, because the first one is more generalizable. Once you're done with that, make sure that you tick all these different boxes to make sure that you have been following them. And before merging, your description should be right over here. Make sure it's concise, short, and to the point. And just for an example, I'll show you the pull request that I had created. So the pull request is right here, and I'll also link the pull request in the description of the video. And the description is very simple. I have made changes to the following 4 properties. The demo examples have been run and verified. I have made sure to run all of these different tests, so we have a check mark on all these items. And I want to summarize the commits, and yeah, that's pretty much it. And as I said, you should run these tests locally because they will be run upstream. And you don't want failure, rerun the test or improve your code and all those messages over here, because that just sends a bad signal that wastes time, not just for you, but also the reviewer. So you don't want to be that person who never tests before pushing the code. And that is how you create a pull request. And let me go back to my 13-step contribution guide. The second last step is respond to feedback. So make sure that you are kind and considerate when you get feedback from the maintainers, because don't take that as a personal attack to your coding skills. It's literally just helping you to write better code. And the last step is merge contributions. Again, you usually don't do anything in this step because that is done by the contributors, but that's usually the finish line. And that is a very good feeling to have your code being a part of a larger repository that is used by thousands of people around the globe. So that is it for this video. We went through all the 13 steps for contributing to the vector repository, and I hope that added some value and you got a better idea about how you can build it, make changes, and make sure you follow all the good practices when making up a request. And I'll try to make sure that I add more videos that are beginner friendly and help you explore more repositories that have really great and impactful code. If you do have some recommendations about repositories or projects that I should contribute to, feel free to put them in the comments. And until then, have a great day, enjoy your life, and happy coding.